Hello everyone, I'm Xiaoliang from Qihu. I'm very happy to Black Hi to share my topic today. The topic of my speech is how to better Fuzz Directx Kernel at present. Okay, this is my introduction. I am a security researcher of Qihu. I thought I will be main focus bug hunting, Windows, and Linux. This is my Twitter. If you are interested, you can Twitter with you can follow me on Twitter. Okay. About S4 IB, which led by this Japan. Okay. We know there has been a lot of research on Directx. This time, I will introduce three attack surfaces to discuss the design of Fuzz. Let's first look at the architecture of Directx. This is architecture diagram from the application layer to the kernel layer through system call such as JDN function, such as Directx and other. Okay, and there are three drivers: DNG, con driver, DNG, MMS1 driver, DNG, MMS2 driver. Okay, and other some drivers such as VMware driver. The next, there is a function exported in the DNG con driver. There are many functions we can fuzzing, and at the same time it also generated a lot of pyramids and objects and others. Okay, such as DHGK map GPU virtual address function. The next, this is the explanation of objects. There are many types of objects. This tab shows the relationship between the application layer and the kernel, and who created these objects. Okay, the figure on the right shows them the appearance in the kernel, how to apply for memory and initialize memory, use this and destroy the. Okay, the next. I will introduce the related attack surfaces. We know WinSaki has many bugs caused by system mechanisms, such as WinSaki callback. So what about Directx? We decided to explore the Directx system mechanism. First attack surface, I call it looking for unreleased memory. Find where some unreleased memory is released. We know Directx use DSJK share object function or some function with different with shared flags to get shared memory and use it in the kernel. But we didn't find any functions to destroy these shared memories. So research, we found that it was the system to destroy these shared functions, shared memory. When the process is destroyed, the process causes them to release the shared memory, such as DSJK display manager delete proceed function and DSJK shared protected function of OB delete proceed function. Okay, and there may be some surprise if the handle is called deployed to use the system to release memory. I believe there are other system mechanisms which maybe is good direct intentions for Directx. Okay. The second attack surface I call getting more paths with different flags. Okay, we found that the direct function has many flag settings, which can create different corner objects that affect in the corner, such as create S1C object. It has uh, different flags. Over these different flags allow it to represent the different contents in the corner. It can represent object of 8 uh, or object of 11, and we call it object mark. And in other functions, it can get more paths in the same function because of its different flags. Use these different flags to generate different objects. These objects take different paths when they are referenced in other functions, so this can increase our feedback rate, coverage feedback rate. Okay, the figure shows the flag struct all related functions and the object marked in the corner, such as Directx create context virtual function, object mark is 7, and flag descend DDI create counter flags. Okay. The next here is the content in the corner after setting the flag. In the corner, a function can have different parameters. A function can create objects of different flags. The flag determines their call path and attributes in the corner. The figure on the right shows this model. The object 2 and the object 3 is the same object with different flags and referenced in the same functions. So this object can have different object mark in the corner. Okay. Next, using setting a flag to generate more paths, such as setting flags from A function to B function and generate from B function to C function, where we means A function decided to C function. Okay, the flag determines a lot of paths. Parent function, sum function, greater sum function. This me. And the next, reverse. We found that the structures of some function of Directx is not public or has been changed. So a lot of reverse and we get private date structures and assign value to them, thus breaking the files that people hadn't explored before in public. Take the opportunity to study these pyramids and to capture the bug, such as this CVEs. This is CVE. This CVE, we found it. The left side of its sum path function. The picture in the upper right corner is a screenshot of bug, and the following the bug after initialize through MEM set function, which is it is passed by MEM set function. Yes, it's simply that the memory is not initialized and then goes to uh, application layer. This bug is found through reverse. Okay, when we have discovered some attack surfaces, we use these attack surfaces to design Fuzz. Let's start to Fuzz. Then we found this dump file, and the next. We know the recent Fuzz about the Linux kernel has talked about a lot of things about blocks like this: open, read, and close. We think it is very important for our Fuzz, so we have also combined a lot of blocks and random calls them. Sometimes a function is selected, sometimes B function is selected, but some function must be called, such as open function. Okay. The next is our Fuzz framework. The Fuzz the Fuzz design based on the AFM model, and we have random seed and block seed, and read the memory, patch the parameters, and mutation the parameters. The mutation comes from the mutation idea comes from syscaller fuzzer and the fuzz loop. But we have a unique fuzz model. We have a new idea. It's a fuzz model. We have a fuzz model similar to one-cycle callback, which means the first attack, and we have fuzz model 2 for flag. We use different flags to create different objects and reverse. We also have a log. We have a logger to record function, which means record a lot of blocks and the same time record parameters. Okay. The next, this is flow code. Okay. Let's look at a few CVEs. That's the first. It's dump file. We can look it, and this and this. This is POC. We can see the handle of Directx create pinch queue function is a parameter of Directx create protected function, and Directx shell objects reference the handle of Directx protected function, and Directx shell and destroy window release the object of Directx create a pinch queue object, and when does destroy window release the object created by Directx create pinch queue function? Because after Directx create protected function is called by Directx shell objects. Directx shell objects doesn't has a special function to release the memory. When the process is destroyed, the function in the first attack service is called to process this shared memory. This function is DSJK shared protected function will be delete procedure. Okay, the memory of DesignDKMT create pinch Q function has been released in the reference of DesignDKMT share objects function. The destroy window is called. Destroy window will call this DSJK shared protected function or be delete procedure function and release this object's memory and cause the bug. Okay, the above is POC. And the next let's talk about the assignment in the corner. On the left, it is the initialize of correct advanced object memory in the corner, and on the right, the corner object of DesignDKMT create page queue in DXG protected function initialize is assigned to the memory of DesignDKMT create protected function. And when DesignDKMT share objects function was called for the fourth time, DSJK S1 object struct which is on the right, DSJ S1C object struct was released. When destroyed window was called, DSJK shared protected function or be delete procedure function was triggered. Finally, it was caused to DNG globe destroy S1C object to release the same memory again and cause the double free. Okay, this is the first attack surface cause the bugs. So I think maybe Directx system mechanism has more surprise. Okay, for the next, for the end, I once again shared CVEs. We clearly recognized that the kernel has a large memory. A large number of memory applications and releases. So after memory is released, if it is not to set 0, if you find another release path, it will cause a second release. The following bug is the DNG MMS2 driver. DNG kernel driver calls the DNG MMS2 driver. Okay. VID MMS process function storage allocated function storage slot alloc memory. That's first. And when the MMS function storage page initialize called free storage release the allocated memory, and where the MMS function storage page delete destructor also called free storage to release the same memory. So we first know the VID MMS function storage page initial is construct, and the VID MMS function storage page delete destruct function is destruct. So the construct and the destruct free the same object, and this free the same memory, and this memory is not set 0. It's amazing. Okay, we can see the red picture V2 in the VID MMS function storage page free storage function is not clear to 0 after release the memory, and we know two paths So after the construct is called, we can call the destruct will trigger both and cause double free. Okay, the next this is dump. We can clear seed, locate, and the next the results. We have some CVEs and some bugs. We will struggle to get more CVE or some important bugs. Okay, the next. I want to say courage. Uh, First, I want to say courage feedback of Windows kernel driver because it's not open the source of Windows kernel. Comment feedback. I think we maybe should have different feedback models for different drivers. Perhaps comment feedback for function call templates is also a good idea, which means we can get more blogs. We can get more blogs, or maybe of course we can use PT driver to increase the coverage of permits. And I think blog is important for the system called Fuzz. And the next new attack service, I think maybe Directx system mechanism is a good idea. Maybe it will give us some surprise. Okay. Maybe we also research the anti driver or Mosaic driver and other driver to get more new research. And okay, the next. This is my acknowledgement. Okay. PGF and Fan Xiaocao. And the next 6 everyone. If you have any questions, you can talk about with you can chat with me in the Twitter on the Twitter. Okay. 6.